So we're going to keep it going with the probability train, but we're going to step it up. We're going to be a little bit more specific. Okay, so, and let me just give you an example of this. I've got this, let's put a title on this, probability. I know, more probability. Okay, and let's start off with an example that we know. All right, first let me give you this spinner. Okay, and first, how about I ask you, what's the probability of spinning a spinner and getting an odd number? Okay, so the probability of just spinning an odd. Well, there's 2 odd numbers out of 3 possibilities. So the probability of spinning an odd, probability of an odd, is 2/3, because there are 2 odds out of 3 total numbers. If I ask you the probability of getting an even, well, there's 1 even out of 3 possibilities, so that would be 1/3. That is stuff that we've done already. Okay, what if I asked you, if I spun the spinner 2 times, what's the probability of getting an odd both times? Okay, so 2 spins, 2 odds. I want the probability of, in 2 spins, getting 2 odds. Well, let's think about the first spin. What's the probability of getting an odd on my first spin? Well, that's 2/3. Then I think about my second spin. What's the probability of getting an odd on my second spin? Well, that's also 2/3. Right? These are independent events. What happened on the first spin does not impact what happened on the second spin. So that's just going to be 4/9. Okay? We could do the same thing with, if I do 3 spins, the probability of getting 3 odds. Okay? Well, the first spin, the probability is 2/3. The second spin is also 2/3. The third spin is also 2/3. Independent events. So we're going to get 8/27 as our probability. This is the stuff that we've been doing. Okay? But we're going to step it up a little bit. Instead of just saying given 2 spins getting 2 odds, or 3 spins getting 3 odds, what if given 3 spins I want exactly 1 odd? Or given 4 spins I want exactly 1 odd. Okay, so now it's not just in general getting odds, it's no, I want the probability of only getting 1 or 2 or 3. So we're doing exact probability. Okay, and I'm going to keep with this spinner. I'm just going to go to another page. All right, so I've still got 1, 2, and 3. Let's do the probability of getting exactly 1 odd. We'll say given 4 spins. Okay, so now it's not the probability of getting an odd, it's the probability of getting exactly 1 odd, given 4 spins. Okay, well, let's think about this, because there are a few different ways that this could happen. All right, I could spin an odd my first time, or I can get an even the first time and get an odd the second time, or I can get my odd the third time, or I can get my odd the fourth time. There are a bunch of different ways or a bunch of different combinations of spins that can give me what I want. Okay, so let's think of, well, so here I'll write, here's my first spin, here's my second spin, here's my third spin, here's my fourth spin. Alright, I could get lucky and roll my odd the first time, or spin my odd the first time. And I know the probability of getting an odd the first time, that's 2/3. But since I already got my odd, the rest of the times I need evens. So for the other spins, I need the probability of getting an even, which is 1/3. Right? So this is the probability of getting an odd my first time and evens the next. And if I go ahead and multiply these, I'm going to get 2/81. But there's another way that this could happen. I could have got my odd the second time around, and everything else would be even. So my 2/3 is going to go for my second spin, and everything else is going to be even. But multiply across, you still get 2/81. My odd could have come during my third spin, and everything else would have been an even. Big surprise, you still get 2 over 81. Or my odd could have happened last, so my 2/3 is going to go for my fourth spin. Obviously, we're not going to write this out every time, but I want you guys to see this. And we're going to get 2 out of 81. Okay? So, if we look at this, there were 4 different combinations of spins that gave me what I wanted, all right? And yes, there's a reason that I keep saying the word combinations, all right? Because we're going to have to use a combination for this. So out of the 4 different combinations of rolls, I wanted one odd. So 4 choose odd there. 4 different combinations that gave me what I wanted. And if you look, I always had a 2/3 in my probability, and I always had 3 1/3. So I've got 1/3 to the 3rd power. This is going to give me my probability of having exactly one odd given in 4 spins. All right, 4 combinations of choosing, or 4 different combinations that have my one odd. So that gives me my 4 choose 1, and then they all had 1 2/3 and 3 1/3. And if you punch that in your calculator, you're going to get 8 over 81. So that's the probability of spinning exactly one odd given 4 spins. See how I'm doing on time. All right. So let's step it up. Instead of exactly 1, then let's do exactly 2. So now let's find the probability of spinning exactly 2 odds given 4 spins. Okay, now I'll go ahead and write out all these possibilities, but it's the last time I'm going to do it because it's a pain in the butt. So here's my first, here's my second, here's my third, and here's my fourth spin. Okay, I could have got lucky. I could have got odd, and the rest would be evens. Or I could have got odd, then an even, then an odd, then an even. Or I could have got odd, even, odd. Okay, so those are all the different ways if I had rolled an odd first. But what if I didn't? What if I had done even, odd, even? Or gotten an even and odd, and then an even and an odd? Or what if I didn't even get an even until my third roll? Okay, so if I look, that's 1, 2, 3, 4, 5, 6 different possibilities. And that's kind of a pain in the butt to figure out. Okay, so instead of listing this out and getting to the point that there's 6 combinations, let's do this in a more efficient way. Let's say, well, I've got 4 spins, right? I've got 4 spins, and I'm looking for combinations of 2 numbers. All right, so 4 choose 2. 4 spins, combinations of 2 numbers. All right, if you put 4 choose 2 in your calculator, you're gonna get 6, which makes sense because I had 6 different combinations right here. Okay, so 4 choose 6. And now, in each of these, I wanted 2 odds. Well, the probability of an odd is 2/3. And that 2/3 happened 2 times. So I'm going to have 2/3 times 2/3 in each of these rows, or it would just be 2/3 squared. But then I also have the probabilities of evens. And the probability of getting an even the probability of an even is 1/3, and that also always happened twice in each of these. So you can go ahead and list these out, or we can do 4 choose 2, and we've got 2/3 squared times 1/3 squared, and if you punch that in your calculator, you're going to get 8 over 27. So that is the probability of getting exactly 2 odds given 4 spins. All right, I'm going to go ahead and do the probability of getting exactly 3, and then we will move on. Okay, so I'll drop my spinner again. Exactly 3 odds given 4 spins. Okay, I'm not going to go ahead and list all these out. Let's think about this. I've got 4 spins, and I'm looking for different ways, different combinations of getting exactly 3 odds. So 4 spins, different combinations of getting exactly 3. That's going to be 4C3. Okay, now if I have 3 odds, well, what's the probability of getting an odd? That's 2/3. And I want that to happen 3 times in each of those different combinations. So it's going to be 2/3 to the third power. And well, if I've got 3 odds and 4 spins, that means I'm going to have 1 even left over. So I'm going to have 1/3 to the first power. I've got 3 odds. That other spot has to be taken by an even. And if you go ahead, punch that in your calculator, you're going to get 32/81 as your probability. Okay? A lot easier than writing out all those different ways. Okay? So 4 spins. I wanted different ways or different combinations of getting 3 odds. Okay? If I want 3 odds, I need the probability of getting an odd to happen 3 times. And then if I'm not an odd, I got to be an even. And that's going to happen the remaining number of times, so 1. Okay, I'm going to do, let's see how I'm doing on time. Perfect. I'm going to do one more example that's not this spinner, just so you get a different context, and then I'm done. Okay, let's do, I've got a fair coin is tossed 10 times. Okay, let's find the probability that it lands on tails exactly 6 times. Right, exactly 6 times. So this isn't given a fair coin toss 10 times, what's the probability of getting a tail? This is find the probability that tails is going to happen exactly 6 times. Alrighty? Well, remember, the probability of a head or a tail is 1/2. It's the same for both. Okay? But if I'm flipping it 10 times, I want to know the different ways or the different combinations that I'm going to get exactly 6 tails. So that is going to be 10 to 6. 10 flips, right? It's tossed 10 times. I want all of the different combinations that I'm going to get a tail for 6 of those. All right? And then for tails, the probability of tails, well, it's 1/2, and I want that to happen 6 times. But then I need the probability of the other thing happening. Well, the other thing happening is heads, and that's also a 1/2. And that needs to happen the remaining number of times. So go ahead, punch that in your calculator, and you're going to get 105/512. That's it. We'll do more problems in class.